All right, in today's notes, we're going to be learning how to graph rational functions. So first thing we need to talk about is a new vocabulary, and it is called an asymptote. And this is basically an invisible boundary line that the graph can't touch or cross. And there are some exceptions to where it can't touch or cross, but we'll get to that later. But in general, 99% of the time, you can't touch it or cross it. So there's two different ways to graph rational functions. The first is when it's in A, H, and K form. And A, H, and K are going to do the same things that they did every time we've worked with A, H, and K this year. So A is going to stretch or flip, H is moving left and right, K is moving up and down. So first let's look at our parent graph. We're going to make a T-chart for that. And if you noticed, I skipped 0. And there's a reason I skipped 0. Let's look at our function. So we have y equals 1 over x. If x is 0, can that happen? Can we divide by 0? No. We've been saying for a while that the domain of this would be x such that x cannot equal 0. And that's why 0 is not included in my t-chart for the parent graph. So what if we did 1 divided by negative 2? That would be negative 0.5. 1 divided by negative 1 is negative 1. 1 divided by positive 1, positive 1. And 1 divided by 2 is positive 1/2. So because the domain is x can't equal 0, and we know we can't divide at 0, we have what's called a vertical asymptote. Remember, vertical goes up and down at x equals 0. We can't touch anywhere along that line. In general, your vertical asymptote is going to be x equals whatever h is. Whatever is going to make this denominator equal 0. We also have a horizontal asymptote. Horizontal goes left to right, so it's going to be a y equals, and it's actually going to be related to whatever k equals. So y cannot equal, what are we adding on the end? Nothing. Y equals 0. So we're going to have a horizontal asymptote at y equals 0. So that means for our range, it's y such that y can equal 0. Be very careful when you're writing these. Make sure when you're writing domain, you're using x's, and when you're writing the range, you're using y's. End behavior. Let's graph it first. So negative 2, negative 1/2, negative 1, negative 1, 1, 1, and 2, and up 1/2. So what this looks like is two little curves like this that don't touch or cross the asymptotes. Now the other thing you need to be careful is these where the asymptotes are, the graph is going to get closer and closer and closer to them, and it's just going to get as close as possible. It's like when you have a sibling and you're on a car ride, they put their finger as close as possible to you and they're like, I'm not touching you, I'm not touching you, I'm not touching you, and try and get closer and closer and closer, but they don't touch you because they just want to annoy you. That's basically how the graph and the asymptotes work. The other thing about the asymptotes is that when you curve this, you're not going to curve back up like this. It's going to curve straight out towards the asymptote. Now for our end behavior, we're still going to use as x goes to positive infinity and as x goes to negative infinity. What is f of x doing? And this is where f of x finally does something different than just go to positive infinity or negative infinity. If you look, the arrow on the right, the very right-hand side, this arrow over here, it's not pointing up and it's not pointing down. It's pointing sideways. Where is this arrow getting closer and closer to? What y value? It's trying to get as close as possible to this asymptote. Where's our asymptote? It's at 0. Same idea on the left arrow. It's not going up, it's not going down, it's going as close and as close as possible to that asymptote that is at 0. So let's look at one where h and k aren't 0. I'm actually going to copy and paste our parent graph. Oop, is it going to let me? I'll just rewrite it. All right, so I'm going to bring our parent graph over, or sorry, a parent chart. So here, a is on the top, it's 1. If a was -1, sometimes they'll put the negative up here. Sometimes they'll try to trick you and they'll put it like in front of the fraction. So watch out for that. H would be 2. Remember, h is always the opposite of what it looks like. And k is 1. So from that, we know our vertical asymptote is x equals 2. Our horizontal asymptote is y equals 1. So I'm going to go ahead and graph those. X equals 2. Y equals 1. Our domain, x such that x does not equal 2. Basically just bring down the vertical asymptote, put a slash through equal sign, and the range y such that y cannot equal 1. That one gets the horizontal asymptote. So since a is 1, we don't need to change our chart at all. And we're going to plot these points. Who remembers where we start when we're graphing in AH and K form? That's right, we start from where H and K meet. So from here, -2, -0.5, -1, -1, +1, +1, and +2, +0.5. So where is our end behavior going this time? This end's going towards what y value? 1. This end is going towards, same thing, it's also going towards 1. These numbers should match up with your horizontal asymptote. So now let's look at an example where a does not equal 1. So here, a is 2, h is -3, and k is -2. Copy down the parent chart. All right, now let's take a look at these big gray boxes at the bottom of your paper. These are similar to a drag and drop problem you might have on the SOL. So what this wants you to do is pick from these choices, pick out the horizontal asymptote and put it in this box, and pick out the vertical asymptote and put it in this box. Now the thing is, if you get the boxes backwards, the SOL is not going to give you any points. You got to make sure the right equation is in the right box. So horizontal. If you haven't heard this before, hoi vox. Horizontal lines have 0 slope and are y equals. Vertical lines have undefined slope and are x equals. So in this horizontal asymptote box, we need to make sure we pick out an equation with y equals. For a vertical asymptote, we need to make sure we pick out an equation that's x equals. Very, very important. If you got the right number but the wrong letter, SOL is going to count it wrong. So, horizontal asymptote, that's your k value. K is -2, so that should be y equals -2. Your vertical asymptote is your h value. H is -3. So based on those, we should know that our domain is x such that x does not equal -3, and our range is y such that y does not equal -2. So let's draw our asymptotes on our graph. Now, a is not 1 this time, so that means we have to multiply all our a values by 2. Then we can graph our original x values with our new y values. So, -2, -1, -1, -2, +1, +2, and +2, +1. So what this did was pulled our curve a little bit out further from the corner. So if it was like 5, it'd be out here. What do you think would happen to it if a was negative? Instead of being in these quadrants, it would switch and be in these quadrants.